Very good, sorry about that.
Yeah. So we are continuing our lectures on stability, and today we will talk about linear systems. So amongst the infinite amount of systems that exist, there is a small class of systems that is governed by linear constant coefficient equations. Now, consider the following system. dxj dt equals summation ajk xk, where j runs from 1 to n. Or in the matrix form, this looks like x dot. Okay, the derivative, this dot is derivative with respect to time. X dot equals ax. Now, we can, I'm just explaining to you that this is actually a row which is a transpose of column x. So x itself is a column. And just because it is easier to write a row, therefore I'm writing the transpose of that column. Okay, and that is x1, x2, xn. And A is this matrix. A sub 1, 1, sub A1, 2, etc., A1n. Now, these are actually coefficients of the system. Now, 1, 1 actually says that this element is in the first row and first column. 2, 1 means it is in the second row and first column, etc. First index tells us the row number, and second index gives us a column number, as we know. Now, we want to discuss stability of the system. So Lyapunov says we would like to use Lyapunov's theory for this system. And for this system, we will construct some function, v of x, that is this Lyapunov function, that equals x transpose bx, where b is a symmetric and positive definite matrix that we don't know yet. Now, what is this writing actually? I mean, I will just write down this writing. So, this is x transpose bx. So, let us calculate first bx. That is b11. Imagine that we will take 2 by 2. b12, b21, b22. And then it is x1, x2. So then this equals b11 x1 plus b12 x2. And then here we get b2 x1 plus b22 x2. Okay, so if I want this element, then I'm taking this one and multiply by each other. Now we calculate x transpose bx. So because x equals x1, x2, x transpose equals x1, x2. Okay? So therefore x transpose bx, that we already calculated, equals x1, x2. And here is b11 x1 plus b12 x2, b2. What is this b2? The course is about instability. Okay. That is b21. So b21. So b21 x1 plus b22 x2. And then this equals a number, actually. This first number is multiplied by this. x1 times b11 x1 plus b12 x2 plus x2 times b21 x1 plus b22 x2. And this gives us actually b11 x1 square plus b12 x2 x1 x2 plus b21 x1 x2 plus b22 x2 square. Okay? Now, if B is a symmetric matrix, then B12 equals B21. And therefore, these terms will be the same. So therefore, X transpose Bx equals actually B11 x1 squared plus 2 times B12 x1 x2 plus B22 x2 squared. So that is a quadratic form. Okay. In case that we have 2 by 2 matrix. But in our general case, we have n by n matrix. Okay, so it contains what? B1, it contains B11 times x1 square, B22 times x2 square. Let me write it down maybe. That will be, in general case, X transpose Bx equals B11 x1 square plus B22 x2 square plus etc. Bnn xn square. Then 2 times B12 x1 x2 plus 2 times B13 x1 x3 plus 2 times B1n x1 xn. Then will be 2 times B, that was 1, 2. Then we will have so 2, 1 is already taken care here. So it will be 2, 3x, 2x3 plus 2 times B2, 4, x3, x2, x4, etc. 2 times B2n, x2, xn. And then will be 2 times. B1, 3 is 1, 2 is taken care of here. 1, 3 is taken care of here, etc. So we will come that 3, 1 is taken care of because B1, 3 is here. So 3, 2 is taken care here. So it will be B3, 4. Okay, that's 3, 4, x3, x4, etc., etc. And at the end will be 2, B n minus 1, n x, n minus 1, xn. Okay, that is a general case. So what we are saying actually is that we would like to look at Lyapunov function as X transpose Bx. So this is a linear system. We look at it as a quadratic form. Okay? Now let us calculate dv dt. We have to calculate dv dt. Now, that will be, let us calculate it. So, again, we have V equals X transpose Bx. What depends upon time? X depends upon time. B is a constant coefficient matrix. It does not depend upon time. So, when I differentiate with respect to time, will be first I differentiate Okay, this first one, x transpose dot bx plus x transpose b x dot. Okay, we differentiate it as a product. Now we say we have to take, Lyapunov's theorem said, in conjunction with differential equations. In conjunction with differential equations means that instead of, we have to substitute the differential equation itself. Which differential equation is x dot equals ax. Is it right? X dot equals ax. Now, how to calculate now x dot transpose? That is what we have, is it right? X dot transpose equals ax transpose. Is it right? Now, one can prove actually, why don't you write down that this is a homework, but it is a very trivial homework, that that is actually x transpose A transpose. Okay? If you are transposing product of matrices, then transpose of the product equals to the product of the transpose in reverse order. Okay, that is a simple exercise, a simple problem. So, therefore, we have here x dot transpose. So x dot transpose, I'm substituting then this one, x transpose A transpose. I get x transpose A transpose, and then I have bx. So that will be x transpose A transpose bx. Then plus, there is x transpose b, and then x dot equals actually ax. Because differential equation says x dot equals ax. So that is this governing differential equation. So therefore we got this. Now here I can see actually that x transpose can be taken out because here is x transpose and here is x transpose. On the right hand side there is x and x. So I can take out x transpose from the left and x from the right. And I'm getting x transpose A transpose B plus BA. These are the two matrices. Now, paying attention, just remember, you have to write here, I don't want to write on these pages, that A is known and B is not. Because A is a given system. But B, we are looking. Now, what does Lyapunov say? Lyapunov says, okay, so we calculate the derivative. That is its derivative. Now, Lyapunov says, if, according to the second theorem of Lyapunov, the equilibrium state is asymptotically stable, if this derivative is negative positive, is it negative? Because V is positive itself. Why is it positive? Because look, x transpose bx, and we said that B is a symmetric and positive definite matrix. If B is a positive definite matrix, then capital V is a positive definite expression. It always takes positive values, never takes negative values. Now, if V is positive, then its total derivative must be negative. That is what Lyapunov says. Function should be positive and its total derivative should be negative. Now when that means that if this is a minus sign, that Q should be positive definite, because x transpose Qx should be positive, then minus something positive will be negative. Okay, so that is what he says. That means that if we can reduce A transpose B plus BA, if we can find such B that this sum will be represented as minus Q, then everything is okay. That is what Lyapunov says. And then he says, actually, look, what Lyapunov's theorem is extremely powerful, because what it says, if I can find such a matrix, that I don't need any numerical calculations. I don't have to integrate differential equation itself. I don't have to look what happens with the solution in time. I don't have to solve problem on computer. I just observe, I am looking at it, so to say, at the equations. And if I can construct such a function, then I'm done. I don't need any computer analysis. Okay, during Lyapunov's time there was no computer analysis, but therefore his theorem is even more important now, because we may avoid numerical calculations. Why we may avoid numerical calculations? Because if I can get something free of charge analytically, why do I have to spend time? My time is very valuable. I can do something else. I can do some other scientific analysis, or maybe even go to a movie, for example. Now, let us consider an example. An example will be as follows. We want to determine the asymptotic stability of equilibrium state x1 equals x2 equals 0 of the following system. And that is a system. First derivative of x1 equals minus x1 minus ax2. And then first derivative of x2 equals x1 minus 4x2. Okay? A is given. A is some number. Look, we write differential equations. These are differential equations in deviations. And we are asked, okay, can you look at that system and tell me, is it stable or not stable? Okay? Just by looking at it. This is almost like alternative medicine, where you bring person to a doctor, and doctor looks at the person, and by look determines what is a problem, without sending to the laboratory, so to say. And, okay, what is this matrix A in this particular case? So that is x dot equals ax. So that is minus 1 here, and that is minus a here. Here is 1 in front of x1, and minus 4. So that is matrix A, our matrix A. Now, let us take as Q simplest case here, okay, simplest case. To have negative is just to take Q equals 1, a unity matrix. So let us take, if we can have Q equals I matrix. I matrix is 1, 1 on diagonals, and 0 off diagonal. So that is this unity matrix. I equals 1, 1, 0, 0. Okay, that is a definition. Okay, that is a definition of unity matrix. If you have not heard it, now you hear it. So you have heard it already. So it's a past. So we are looking at these equations, and we say A transpose B plus BA equals minus I. Okay, let us calculate A transpose B. Okay, here. What is A transpose B? That is A, yes, A. 1 minus A, 1 minus 4. Transpose means that we are exchanging the off-diagonal terms with each other. So that is principal diagonal. So here I'm writing 1, and here minus A. So that is it. 1 and minus A. Times B. B1, 1, B1, 2, B2, 1, B2, 2. Plus BA. Okay? That is B1, 1, B1, 2, B2, 1, B2, 2, times minus 1A, minus A, 1, minus 4. So, and this should equal I, minus 1, 0, 0, minus 1. Okay? So that is what we want. That will be the simplest task for us. I mean, that will be the simplest thing for us. If that happens, then we are done. We can sleep. We don't have to calculate anything. Now, we assume that B is a symmetric matrix, means B21 equals B12. Now, then this yields as follows. Look, let us calculate then this equation. So this is a matrix, of course, 2 by 2 matrix. So we calculate the first element, minus 1 times B11 plus 1 times B21. Now here is B11 times minus 1. That will be added to it. I will get the minus 2 times B11. B12 times 1, so it will be added to 1 times B12, will be 2 times B12 equals minus 1. That is the first equation. So again, this multiplied by this multiplied by this, and it equals this term. Now, second thing, this multiplied by this, and this multiplied by these terms. Okay, so I'm getting minus A times B11. Then I multiplied everything by minus sign. So I'm getting A times B11. Then B12 times which term I'm looking for? This times this times this, that equals 0. I don't understand where this 5 comes from. Please check at home. And then here we are getting, third equation is 2 times A, B12. That is probably this term. No, this term. This term. Plus H times B22 equals 1. Now I'm maintaining that 2 equations here are identical. So in total I have 4 equations, because when I multiply I'm getting matrix 2 by 2, and that is 2 by 2. So I have 4 equations, because I have to equate left-hand sides and right-hand sides. But 2 equations are coinciding. Then if that is the case, we can solve from here B. B11 equals 21 plus A, 10A plus 40. I'm just solving these equations by hand. B12 equals 1 minus 4A divided by 10A plus 40. B22 equals A plus A squared plus 5, 10A plus 40. Therefore, matrix B becomes, look, B equals 1 over, this can be taken out, 10A plus 40, 21 plus A, then will be 1 minus 4A, and then here we get A plus A squared plus 5. Okay? Now I'm suggesting that let us find the eigenvalues of this matrix B. Eigenvalues means that on diagonals we write minus lambda, and we get an equation for determinant that must be 0. So 21 plus A minus lambda here, A plus A squared plus 5 minus lambda equals 0. And consider the case when A equals 2. Imagine that this A equals 2 in the equation. Then we get this equation. Both eigenvalues, 17 plus square root from 85, that is the first root. Second root is 17 minus square root from 85. Well, square root from 85 is a bit more than 9. So 17 plus minus 9 are both positive. So that means that B is a positive definite matrix. If its eigenvalues are positive, then it is a positive definite matrix. Lyapunov function is positive definite. The total derivative is negative definite. Therefore, equilibrium state is asymptotically stable. Trust me that this analysis is much cheaper time-wise than to do it on computers, because before you are setting your computer system, then you have to find that your computer does correctly benchmark problems of which you know the solution. Then you will prove that it is bug-free and there are no mistakes, etc. Even the simple problem may take much time. And there also, analysis should be confined. I mean, you have to consider stability on a long time interval. I mean, it's quite much work to do it numerically. Naturally, we have to go to numerics when we have to, but we don't have to do numerics when we can do it analytically. Okay? Also, there is one very big thing, that knowing analytical solutions are very helpful for your numerical calculations, because if you have difficult problems that should be solved numerically, at least you can consider some particular case, some parameter is small or maybe negligible. Then for that particular case, you can do analytical calculation. Then you can check, does your numerical calculation for general case reduce to your analytical calculation for that particular case where you can get analytical calculation? At least your confidence is increasing. So never do only numerical analysis. Naturally, in modern times, we can also never do analytical analysis. That is not possible, just simply impossible. But they must go hand by hand. So the decision I'm writing here, whether or not the unperturbed state is stable, can be derived in the linear system linear case by straightforward calculation. Now, what we are saying is as follows, that in the linear systems, we actually do not need to go to Lyapunov calculations. Now, I will prove. In the linear case, one does not have to go to Lyapunov functions. This is illustrated in the following discussion, and we will do that. But now I would like to assign homework so that we will not be left homework-less. Okay. So consider this example, dx1 dt equals minus x1 minus ax2, dx2 dt equals x1 minus 4x2. Now choose A equals last digit in your social security number if that is not 0. If it is 0, then previous number, etc. If there are two things are 0, then you go, I hope that your number is not composed only of all zeros. Okay? There is one number that is not 0. Okay? And perform analysis. Also check the case in the notes. A equals 2, I think, yes? So check the case. Because suddenly there was this 5 there. I did not understand where 5 came from. Okay, stability of second order system. So we will deal now with stability of the second order system without going to Lyapunov functions. So we consider simplest case, that is second order differential equation. Second order system means dx1 dt equals a11 x1 plus a12 x2, dx2 dt equals a21 x1 plus a22 x2, and let us say also that the determinant of these coefficients, and we will see why later, a11 a22 minus a12 a21 is not 0. Okay? Now, x1t, x2t. That means that t is a parameter, actually, of this system. And the coordinates of a point moving in x1, x2 planes, the curve traced out, directed by increasing t, is called trajectory. Means that if we will consider system and, say, coordinate system, x1, x2, 0, but x1 depends upon t, x2 depends upon t. That means that when t is some number, then x1 I can calculate and x2 I can calculate, so I'm getting a point. For another t, a bit more t, then I can calculate x1 if I know the solution. So what I'm saying is that we are getting some curve here. And this curve is called the trajectory. Okay? We can calculate the coordinate system x1, x2. How do I get x1? If I know x1 is a function of t, then I will substitute t and I will get x1. x2 equals x2 of t. I substitute t, I get x2. Okay? So I just substitute two things. For example, some could be interested, for example, that if t is an age of the person, then x1 is, for example, his height, for example. Imagine that someone is interested with how tall the person is, okay? And then that is his width, for example. And then we can depict this function depending upon the age, actually, okay? You give the age. If I know this function and that function, then I'm getting a point every time, for example. Or this could be displacement, and this is velocity. That is displacement, and that is viscosity, for example, etc., etc. Now we want to find the solution. Okay, first of all, how to find this? Okay. In this interpretation, x2, x1 plane is called phase plane. This plane that I depicted to is called phase plane. That means that phase plane is a picture of differential equations solution without time. Time is not there. Time is eliminated. You may want to write it down. Phase plane is without time. There is no time there. And the slope of the trajectory equals dx2 dx1. Is it right? That is a derivative, x2 with respect to x1. So that could be calculated dx2 dt divided by dx1 dt. dx2 dt equals a21 x1 plus a22 x2. dx1 dt equals this right-hand side. So you see, derivative is calculated in terms of the functions, x1 and x2. It's very easy to calculate every time where this trajectory is going because these are given things, right-hand side. Okay, now let us forget this phase plane for 1 second, and we will seek solutions in the form x1 of t equals x1 of t equals a times e in power rt, x2 equals b times e in power rt. I substitute these two into these differential equations. And I get a11 minus r times a plus a12 times b equals 0. Second will be a21a plus a22 minus r, b equals 0. Okay? You are with me? That is very, very trivial. For this homogeneous system of equations to have a non-trivial solution, it is necessary and sufficient determinant of coefficients to vanish. And this determinant is given on page 25. What is this? A11 minus R, A12, A21, A22 minus R. And that can be written just like this. That is R, I just calculated it. R square minus A11 plus A22R plus, that is a determinant. A11, A22 minus A12, A21 equals 0. Pay attention why I wanted determinant to be non-zero. Because if determinant is 0, then one of the R's is 0. Is it right? If this is 0, then R equals 0 is a solution. I just did not want to consider that case. Okay, because if R is 0, that means that E in power RT is, is 1, and then therefore solution is a constant, not a function of time. I did not want to deal with this. Okay, there could be several cases. Here could be several cases. Unequal real roots. Okay, unequal real roots means R1 and R2. Then x1 equals A1 e in power R1t plus A2 e in power R2t. And then x2 equals this, A1 times, I will prove that to you, C1 e in power RT plus A2 times C2 in power R2t, where C1 and C2 are given. But the main thing is that, I will prove that next time, but if R1 and R2 are negative, okay, then we see that this function is decaying when t goes to infinity. If R1 and R2 are negative. So what we will prove next time, that when R1 and R2 are negative, then unperturbed motion is asymptotically stable. Okay, that I will prove next time. Now we will go to our Euler columns. This is also our subject, but this is not a column. This is just a simple set of differential equations. Okay? Did you do this clamped beam, clamped column? Do you remember I asked you to find why the buckling load of the clamped column equals 4 times buckling load of the simply supported column? Did you find that reason? Maybe you can tell me reasons and I will write down here. I don't want to take much time by bringing a student here. Okay, I will write it down. So my question is, we had. Okay, but before that we say P simply supported equals pi square EI over L square. And P clamped equals 4 pi square EI over L square. That is simply supported, clamped. So PCC equals 4 times PSS. When we have such a relationship, when we get such relations, we must is too strong, of course, yes? It is recommended to wonder, okay, to think why such an exact relationship. Can it be explained somehow? look, if the answer was 3.9, we can still ask this question, why is 3.9? But when it is 4, then it is really asking us to ask the question, why this is exactly 4? Is there some underlying reason for this 4 to come out? So what are the answers? Let us start from Miss Gentilini. Deformed shape. So what does it mean? Can you be more explicit? Deformed shape. You mean mode shape? Simply supported column has such a form.
Yes. On the contrary, the clamp column.
Yes.
The end can rotate, and so on. The mode shape is different.
Mode shape is different. So that is a mode shape. Maybe I can even depict it a bit better. Okay, so what? Mode shapes are different.
So we have in the first case one wave.
So here we have, she says, Miss Gentilini says, 1/2 sine wave.
In the second, we have two.
Here we have 2. Where do you see that 2? That is what she says, actually. Where do you see 2? Now, if simply supported beam in second buckling load, that has two half waves. So for second P2 equals 4 pi square EI over L square. That is simply supported. Here I see first half wave, first one, and that is second. Where do I see here 2 sine waves? Okay, Miss Santoro, that's interesting, thank you.
In the length plane, the free span of deflection.
Yes, can you?
Free span of deflection is L over 2.
Free span of the, what is free span? Oh, okay, she does not know English. Okay, Mr. Say it again.
It's L over 2 if I consider the.
Okay, so what is L over 2? Let me write it down. Miss Santoro, she says something is L over 2. What is in Italian?
Luce libera, l'impressione.
What is luce? Distance, libera. Right. Okay, maybe okay, Mr. Valencia. Placencia. Sorry, Mr. Placencia. Say it again.
For the simple support beam, the mode shape, which is the shape of which the column buckles, is sine
Pi x over L.
yes.
1 minus cosine
KL over 2. So sine KL over 2.
KL over 2. KL over 2 is cannot
Sine
1 minus cosine isotope, but tell me what it is. Why don't you look?
sine KL over 2.
It cannot be sine KL over 2 because KL over 2 is a constant. Sine KL over 2 will be a constant number. It should depend upon x. Okay, now let us discuss what Ms. Santoro said that is in correct direction. The only thing is that we need some more explanation. I would like, let us add this second homework. Please find the mode shape of the clamped column. Mr. Plasencia did say that that is sine KL over 2. That is this transcendental equation. But we want to find W of x equals some constant, a times some function. Oh, yes, Mr. Gomez.
I have a question. The picture you have drawn.
I'm looking for answers, and here's a question. Okay, here's a question.
The picture you have drawn with the two half sine waves.
Yeah, that is actually a simply supported beam. So what happens is as follows. Simply second buckling load of the simply supported beam coincides numerically with the first buckling load of clamped beam. So it is just an additional information. Do you remember we had here PSS equals n pi square EI over L square. So when n equals 1, we have pi square. When n equals 2, we get 4 pi square. So P2 SS equals P1 CC. That is an interesting observation. Whether it is a helpful observation or not, that is a different story. But that is an interesting observation, that second buckling load of simply supported column coincides with the first one of clamped one.
Because I was going to say, if that is P2 is equal to 4 pi squared EI over L squared, it's the same as the first buckling load of the clamp. But it would appear that you would have a restriction in the middle, but for clamp, you have restrictions on the sides.
Yeah, so these are different stories, so to say. They are different stories from that point of view. Any observation? No, so you don't want to contribute to confusion. Okay, so we answered this question. Yeah, you see, one thing is the eigenvalues, they are coinciding. But second thing is modes, they do not coincide. Why? Because modes cannot coincide because modes should satisfy the boundary conditions. And simply supported and clamped are different stories. Okay, they are, so to say, arias coming from different operas. They cannot coincide. So, what I'm saying is as follows. And please check, first of all, find this. Then, when you will find this function, please find something that is called a point where second derivative equals 0. Say it again. Yeah, inflection point. And then this is a second point here, where also second derivative equals 0 of that function. And indeed it should be 0. Why? Because look, because the first derivative is 0, function should rise in the beginning like this. Yes? But it should come to 0. So it means that it should somewhere have an inflection point. Otherwise it will not get there. Again, it starts like this. First derivative must be 0 here. So the curve should start so that first derivative is 0. So it starts like this. But it cannot go like this. And otherwise it will go, to Boynton Beach or somewhere else. It has to change the direction. Because it has to change the direction, there is this inflection point. Because there is this inflection point, look please, we can actually think that we have a beam between these 2 points. And now this beam between these 2 points has second derivatives are 0. And if that is a coordinate system, then also the displacements are there 0, so to say. And therefore, this clamped beam behaves as a simply supported beam of this length. And let us call it L star. And if that is the case, we will get, look please, P critical, clamped, equals 4 pi square EI over L square. This equals to pi square EI over L star squared. And Ms. Santoro is right that in order this to happen, this L star should be what? It should be L over 2. Otherwise, this will never take place. So that means that you should check. Now we know what to anticipate. We should check that between these inflection points, the distance must be L over 2.
What's the English form of that distance?
Say it again. And this distance, okay, at least in English language, there is no term for it. But you said that in Italian there is this term, which is called what? Free distance?
Yes.
Free distance. Why it is free? Okay, I don't know. Maybe you can read why it says somewhere why it is called. I have a book by Corrado. You can stop by. Maybe I have here or at home. I should check. Maybe there will be an explanation why they call so. Okay, so that is an interesting observation. Now, second thing is a column simply supported we did consider. Column clamped on both ends. So we can consider with the column that is simply supported at one end and clamped on the other. So okay, let us see. PSS equals pi square EI over L square. PCC equals 4 pi square EI over L square. Now I want to find PSC, simply supported clamped. So this beam is or clamped, simply supported. For example, like this. And that is a load. Or it is simply supported here. And here it is clamped. So it's the same. So just a question. Sorry for this question. Sorry because if this is Okay, imagine that this is P, we know that PSS equals pi square here. We know that PCC equals 4 pi square. So can you anticipate what would be PSC?
16.
Say it again.
16.
16 what?
16 pi squared.
16. Okay, let me write it down because I must give credit. So 16 pi square EI over L square. That is suggestion by Mr. Gomez. What else? 2 pi square EI over L square. Mr. Plasencia. Why did you suggest for 16?
Because clamp in 4 times the value of P is simple sim.
Oh. But look, okay, okay. If this is 4 times, you said, then something new should be 16. No, look, that is what I understand. That. Look, if you have 1 pi square, and the next case was 4 pi square, therefore a brand new case should be 4 times more. That was your reasoning, I think. Okay, so therefore it should be 16 pi square. Okay, Mr. Plasencia said not 16, but 2. Why 2?
Because if we have clamp and it's 4, if we have just one side clamp, it's 2, half of it.
Okay, so he says that it is 1/2, but it is also half of simply supported. Okay. If that is look, he says that because only 1 is clamped, therefore I take half of 4. But we can also tell you, look, please, it is only 1 is simply supported, then we can take half of pi square. You understand what I'm saying? If you say that it is 1/2 of 4 pi square EI over L square, then why not 1/2 of pi square EI over L square? That is the question. Okay, Mr. Penteras. Don't say I don't know, otherwise I'll take this television throw at you. You cannot just be indifferent, you know. I don't care, I don't know. Say something, participate. 6? 6 pi square over L square. Okay, that was Gomez, Plasencia, that is Penteras. So P2, that means P1. What about G? That is Gomez 1. G2, Gentilini.
Depends from the mount shape.
Okay, don't tell us. We know that it depends on mount shape. I want the number.
0.6.
0.6?
No. L star.
Don't give me L star. I want in terms of L. I want you to write, look, pi square EI over L square, and then give your number here. Yes.
1 over 0.6 squared.
How did you get this?
No, but I don't remember very well the number.
Oh, you are trying to remember from a course that you studied.
Yeah.
I see. So you don't remember. But look, it's a bit unfair. Why? Because if you remember, then it's fair to say, look, I remember and I know I don't have to guess. But if others don't know and they did guess, so to say, honestly, maybe incorrectly. So what I want from you is not to remember or not to remember, but can you justify? Look, Mr. Gomez justified very beautifully. Maybe it would be very wrong. We will see. He said that because once we multiplied by 4, now I also multiply by another 4. Okay, that is a beautiful justification. It may be very wrong. By the way, I must tell you that it is also very wrong. But
So, it is a number between the simply supported and the clamp.
okay, so this number you say is alpha, and that is between pi square and 4 pi square. Okay, okay, that I understand because boundary conditions are in between. Okay, Miss Santoro.
Yes, the same answer.
No, we want something more specific. You know, this is she gave us a you know, an interval. Okay, so for example, she thinks that it cannot be 16. Why do you think it can? Why Mr. Gomez is wrong? Yeah.
Because
Excuse me, let us ask Mr. Penteras. Why Mr. Gomez is wrong? Why Mr. Gomez is wrong? Mr. Plasencia, why Mr. Gomez is wrong? Do you work in a restaurant at night and you are still not yet? Huh? Okay. Mr. Plasencia, Mr. Gomez is wrong. Why? Okay, you can answer because his last name starts with G. But I don't want such an answer. Why is he wrong? Look, please. Look, we have imagine that we have this problem and we don't know how to solve, and we ask two experts. And expert number 1 is Mr. Gomez, and expert number 2 is Miss Gentilini. Now, one expert says between pi square to 4 pi square. Now, second expert says it is 16 pi square. Now, look please, if it is 16, means danger is very far away from us, yes? Because 16 pi square is approximately 160. And here it is between 10 to 40. Okay? So these are very different numbers, just for us to understand. So we have to think why this expert can be wrong. So why is he wrong? Miss Santoro.
It means that simply support clamp beams bubbles before a simply support beam.
Yeah, which cannot be, yeah? Because simply supported clamped beam is less strong naturally than clamped beam. And why in the world less strong system buckle at a very high load? It should buckle before that, before such a number. That cannot possibly be, but it is a nice suggestion. I just did not understand one thing why you did not suggest. And it's a bit surprising to me that because first idea that comes to the one's mind is what number? What number should come to person's head immediately? Simply supported is 10 approximately. Clamped is 40. So now this is simply supported and clamped. So how much would come to mind? again, here is 10, 10, here is 40. And this case is what kind of case? In mixture. So what number would we think that would be? 25. Okay, that is, I'm surprised that most natural number that one can think of, no one suggested. And that is approximately 2.5 pi square, is it right? Something like 2.5 pi square. Look, if here is pi square and this is 4 pi square, then here I would anticipate that it is pi square plus 4 pi square together is 5 pi square, divided by 2 will be 2.5 pi square.
I was close, it said 2.
Yes?
How come you go from simply supported to clamp? Why don't you go from simply supported to simply clamp?
No, it's the same. Simply clamped or clamped simply supported is the same case. Because clamped simply supported is if I'm looking from here. But if I'm looking from here at this system, it's simply supported clamp, and it's the same system.
I mean, in the explanation of the topic.
In the explanation of the topic, I went in these directions because I wanted so. Thank you.